Alright, sorry I got homework after a test, but I wanted to get us started with the next chapter this evening, something very important, something maybe you have seen before. We're going to be going over slope. So slope is the ratio comparing the vertical change to the horizontal change of a graph. So what we have been doing is looking at a bunch of functions and looking how to graph them, thinking about how they're changing, and now we're going to have this word that I'm sure, again, you're probably familiar with to talk about this stuff. So looking at this first example, the car is about to climb a hill. How could we describe the slope of the hill as it is climbing? So if we are going to figure out how it is changing, it's really good to talk about how it is changing vertically and how it is changing horizontally. So as the car is driving up the hill, at the top, it's going to be 3 meters higher than it was, and it's going to be 4 meters further. When we are talking about slope, if you go back up to the top and you read it again, it says the word ratio. Ratios are fractions. So we would put this together for the idea of slope and say that the slope is going to be 3, and I'm going to start with kind of up, over 4 to the right. So slope is this change from where we are to where we're going for the first one, 3 up and 4 right. Taking a look at the bottom one, we're still going to be talking about change vertically and change horizontally. How is the car changing as it drives down the hill? Well, we got to use that word. Vertically, it's going to be going down 3 centimeters. Ooh, that kind of looks ugly. My bad. 3 centimeters. It's going down 3 centimeters. Horizontally, how are we changing? We're still going to the right 4 centimeters. And again, if we're thinking about slope, slope being how much we change vertically over how much we're changing horizontally, this one is going to be down 3 and right 4, over right 4. Okay, this is the idea of slope. So when we flip over to the next page, we see more of a formal definition of slope. Vertical change over horizontal change. Another way to think about that is the change in the y-coordinate over the change in the x-coordinate. You will sometimes see it written over here where I just put a star above with these triangles. This is the character delta. It is, let's erase that to make that more legible. That is the character delta. It's used a lot to represent the word change in math and science. So we could say delta y over delta x to mean change in y over change in x. I got one more thing to write over here. Actually, I got 2. So I want to start with this one that we will be seeing in a little bit. It might be familiar, which is why I'm writing it down. We're going to be using that formula quite a bit in the future. The other thing I'd like for you to write down is this phrase, rise over run. That's going to be our little hint to remember slope. So, let's look at slope from some actual graphs. A lot of these words are going to be used interchangeably, as it says. You'll hear me saying change and rise and run a lot. So let's take a look. How can we find the slope of a line from its graph? Well, you need to use 2 points. And we're going to figure out how much the y-coordinates change. And we're going to put that over how much the x-coordinates change. A lot of times when I do this for graphs, I like to draw a triangle. When I draw this triangle, I always draw up or down first and then to the right. So I'm going to start at the point 0, 5 and draw my triangle by drawing down and to the right. That can sometimes be helpful when trying to find slope. So now we're going to try to figure out how much it changes vertically. If you look at the graph, we are moving down 2. What is the change in the horizontal direction? Well, we start over here. Hopefully you can see where I'm drawing, and then we count over 1 and 2 and 3. So it looks like our change is right 3. Now words like down, hopefully they make you think of negative. We're going to put that change vertically on top of our ratio, our fraction, and we're going to put our horizontal change of 3 down on the bottom, so our slope is negative 2/3. I also want you to look at the other points in this. If we were to draw another triangle in this same graph, find the slope that way. What do you notice? Hopefully you notice something. But I'm going to move on to the last one. The slope of this line. I see my 2 points. I'm going to start with the one on the left and draw my triangle up or down first. So on the left, it looks like we have to go up first. And then I'm going to connect it over to the other point. So we're going to do my change in y over my change in x. So how much does it change in the y direction? You got to count how much it's going up or down. So it's going up 3. Then we count how much it's going to the right. 1 and 2 and 3 and 4 and 5 and 6. So it's going to the right 6. So up is positive, right is positive. We'll be talking about that a little bit more. There's my slope, but I'm not happy with that. I want you to simplify it. Our slope is 1/2 for this line. So go back, think about this, make sure this makes sense. There is a Google form posted on our calendar. I would like for you to go to that Google form and take the check for understanding. It's 2 multiple choice questions, just so I can see if this is making sense here. So thank you for watching. We're going to be getting into lines, slopes, and equations here this chapter, and hopefully we're starting off well. Bye-bye.